right, this is the second block of topic 25. In this lesson, we're going to be looking at calculating surface area of a pyramid. So in question 1 of your notes, you're asked to sketch a net for this pyramid. As you can tell by the base, since it's 4 centimeters in length and 4 centimeters in width, the bottom is the base is a square. So this would be called a square pyramid. And so when you are drawing its net, of course, one of the faces would be that square base, 4 centimeter by 4 centimeter. In pyramids, the lateral faces are all triangles. And so you could have at each one of these sides a triangle coming out from it like so. And of course, I'm not drawing that to scale, but that is a rough look of what your net would look like. You can see it drawn a whole lot better on number 2 in your notes. Now, these are some things for us to think about. What shapes are the lateral faces? Lateral faces of a pyramid are always going to be triangles, and that's what they are in this case as well. And how is the height of the pyramid related to the height of one of those faces? So notice the height of the whole pyramid is 4 centimeters, but that is not the height of the triangle. And so that is going to be really tricky when we start looking at surface area of pyramids, is understanding the height of the lateral face is not the same thing as the height of the whole pyramid. So it says surface area of a pyramid. Satisfied with her findings regarding the volume of a chocolate pyramid, D considers surface area. So Penny is not available to her, so she's got to figure this out on her own this time. So she visualizes unfolding the pyramid into a net, as we will see is done in this animation. So here is the square pyramid that we're looking at. It's 4 centimeters in length and width and height. So we can see here the unfolding of that pyramid gets the net that we sketched and is drawn in number 2 on your notes. So question 2 in our notes is asking us to determine the height and the area of each lateral face of the pyramid. And then we're going to calculate the total surface area. So D recognizes that the net is composed of a square base and 4 congruent isosceles triangles as the lateral faces. She knows how to find the area of a square. Since it's 4 centimeters by 4 centimeters, we know it would have an area of 16 square centimeters. 4 times 4 is 16. And she also remembers how to find the area of a triangle. It's 1/2 base times height. But she recognizes that the height of this triangle, which is shown here, is not the same thing as the height of the pyramid. It's actually going to be a longer distance because if we visualize this right triangle here with the height of the pyramid, then we can see that the height of the triangle is actually the hypotenuse of that triangle. So we know it would be longer. So she draws in this little right triangle with the height of the triangle, and then this base is not the whole length of that square. It's only half of it. So she's labeled that as 2 here. And she knows she can find the height of the triangle by just applying the Pythagorean theorem. So that's what we're going to do here is find the height of the triangle. And this is called the slant height of the pyramid. And we use a cursive L for that. So instead of an H here, you'll get confused between the height of the triangle, of the pyramid, which is 4, with this height of the triangle, which is the slant height. So we use different letters for that. H for the height of the pyramid, L for the slant height of the pyramid, and that's the height of your triangle. So using the Pythagorean theorem here, this is not a Pythagorean triple. We have a 3, 4, 5, but we don't have a 2, 4 something. So we have to use the Pythagorean theorem, 2 squared plus 4 squared, since those are my legs, equals that slant height squared. So we know 2 squared is 4 and 4 squared is 16, and so those add to get 20. So we know the slant height is the square root of 20. We could simplify that, but it's not a perfect square. We know the square root of 20 is the same thing as the square root of 4 times 5. We can take the square root of 4 and bring it out as a 2. So we can simplify it to 2 square roots of 5. But remember, if you're given rounding instructions, don't round here. Round at the very end. So this is what we're going to use as the height of our triangle. So finding the lateral face is finding the area of each one of these triangles and then realizing you have 4 of them. So to find the area of a triangle, remember it is 1/2 base times height, but this height is not the height of the pyramid. This is the slant height we just found. So the base of that triangle was given to us because that was the side of the square. It was 4. And then the height of the triangle was the slant height we just found, which is 2 square roots of 5. So we know half of 4 is 2, and 2 times 2 is 4. So our area of one of those triangles is 4 square roots of 5. That's the area of one of these. And we have 4 of them. So we're going to multiply that by 4 in order to get our lateral area of the whole pyramid. So 4 times 4 is 16. So our lateral area is 16 square roots of 5 centimeters squared. Now, if we were given rounding rules, that's when we could put that into our calculator, 16 square roots of 5. And if we were rounding, like to the nearest tenth or whatever, we could put 35.7. So the lateral area would be approximately 35 actually that would round to 8 since next door is a 7. 35.8 square centimeters. That's the lateral area. This is the area of each one of the faces, but we have 4 of them. So now we can calculate the total surface area. We know the lateral area is 16 square roots of 5, and plus the area of the base, which was the square, which was 4 by 4, which is 16 centimeters squared. Now, if you were not asked to round, remember you can't add these two numbers. They're not like terms. So you would just leave it 16 square roots of 5 plus 16. But if you're given rounding rules, then you can just put 16 square roots of 5. Make sure you right arrow out of that radical before pressing plus 16. And then you can round that number. So the whole surface area is approximately 51.8 square centimeters. Okay, so let's review what we did here. To find the whole surface area of the square pyramid, it has 5 faces that you have to find the areas of. One of them is the base, which is a square, so that's just length times width, which are both 4. And then 4 of them are congruent triangles. And to find the area of a triangle, it's 1/2 base times height. We had to recognize that the height of the triangle, which is right here, is not the same thing as the height of the pyramid, which is right here. We formed that little right triangle and used Pythagorean theorem using half of the side length here as 2 and using the height that was given to us as 4 to find the height of the triangle, which is called the slant height of that pyramid. And we use a cursive L for that. So we used Pythagorean theorem to find that. That allowed us to find the area of one triangle, and we have 4 of those. So this was our lateral area. Our whole surface area is that lateral area plus the area of the base. So this is the exact surface area. This is our rounded answer. Remember, only round once. All right, so let's continue on in our notes here. So remember the general formula for the surface area of a prism or a cylinder, which is like a prism because it has 2 bases, is twice the base area plus the lateral area. So you have 2 of the bases plus what you have along the sides as the lateral. Or we also found twice the base area plus perimeter times height. But pyramids only have pyramids only have 1 base. So they did not have the same formula that you can use for them that you can for a prism. Prisms have 2 bases, pyramids only have 1. So D recognizes the importance of creating a general formula she can use for a pyramid. So she knows that the surface area is the lateral area plus the base area. So she realizes she can be more specific with the one that has a square as the pyramid. So she writes, instead of the base area, she writes S squared. And instead of the lateral area, she writes 4 of the triangles, which is 1/2 base times height. But remember, the base is the side length of the square, and the height we're talking about is the slant height of the pyramid. Okay, so we're using that cursive L as slant height instead of an H, which is the height of the pyramid itself. So here is where we are at that point. Well, we can tell that since this is multiplication, we can write that in any order. So you can tell that she rearranged some of the order here. She wrote the 1/2 and the L first, and then the 4 times the S second. Well, 4 times the side length is the perimeter of that square. So she replaces 4S with a P, which really should be capitalized for perimeter there. And this is the general formula that she comes up with. So question 3 in your notes says, write a more specific formula for surface area of a square pyramid. Use the shape of the base and identify your variables. That's what you're doing right here, this highlighted part. So you can pause the video to write this in for question 3. This is the general formula, and this is what each one of the variables represents. So let's look at question 4 in our notes. We're going to apply what we know to find the surface area of this square pyramid. And I'm going to work it both ways. I'm going to work it the way we did with number 2, and I'm going to work it the way we did with our formula for number 3. Okay, so just the one way to find the surface area is just to understand that you have one square base that you have to find the area of, plus 4 triangles that you have to find the area of. This time it gives you the slant height, so we don't have to use Pythagorean theorem to find it. So your base, your square has a length of 230, length and width, so that would be 230 times itself. And then the triangles would be 4 of the 1/2 base times height. The base is the 230. The height is given to us this time as 186. So this is one way that you can find the surface area. So the area of the base, 230 squared, gives us 52,900. Each one of the triangles is 1/2 of 230 times the 186. And so that's 21,390, but we have 4 of them. So we have to multiply that by 4, and we get 85,560. So we can add the area of the base with the lateral area, and that gives us our total surface area to be 138,460. And remember, since it's area, the units are squared, so meters squared. Now I'm going to work it, and I guess I could make this big. I'm sorry, guys. Now I'm going to work it with using the formula that we came up with in number 3. And so that surface area formula is 1/2 the slant height times the perimeter of the base plus the area of the base, which for a square is side squared. So we would have 1/2, our slant height was given as 186, times the perimeter, which remember is the sum of all the sides, so that would be 230 times 4, you have 4 of them, which is 920, plus the area of the base, which is your side squared. 230 squared we already found up here to be 52,900. So we have, sorry, I can't write for some reason. So we have 1/2 of 186 times 920 gives us 85,560 that we're going to add to 52,900. Notice that's the same thing up here. So of course we get the same answer, 138,460 meters squared. So I don't care which way you work it. If it's easier for you not to memorize another formula and just know you have to find the area of all 5 faces and add them together, that's typically the way I work it. There's just no reason to have to memorize another formula. So that is the lesson for 25-2. Good luck with your homework.